This is Cerebral Contortions number 2 for grade 9. And in this video, I'm going to take up all of the reduced bank for the test for Cerebral Contortions number 2. So in this case, I'm going to take up these 3 first, and then I'm going to go over and take up the next 3. These were the ones that I gave hints to, but I'm going to read them out again, and I'm going to explain how to do these. So for question number 1, it says the exponent of the greatest power of 40 that will divide into 80 factorial with no remainder is. So basically, what I've done here is I said 80 factorial is 80 times 79 times 78, etc. And you can go back and look at the other video if you want a little bit more details on some of this, but I'm going to go through this fairly quickly. So 40, what we said was we have 2 prime factors, and you have 40 as 2 cubed times 5. So you use this prime factoring to find out how many of these will actually divide into this. So you need this whole grouping of 2 cubed times 5, because otherwise you have to figure out how many 40s will go into here. But basically, when you prime factor all of this out, that will tell you how many 40s, and you can just use that prime factoring by looking at the number 2 cubes times 5. But to prime factor that out would be pretty huge, and there's a lot of places for error because you may miss something. So this is an easier way to do it. So we check the number of 2's and the number of 5's that will divide into this. So the first thing is start with number of 2's. So you start with 80, and you say, okay, 80 divided by 2 will give you 40. So you know you have at least 40 in there. But that's just telling you there's at least 1. Now, another, like if you know there's 40 left there, then you know 40 can be divisible by 2 to get 2 squared. You want to know how many squares there are. So that gives you 20 plus numbers that may contain 2 squared plus 2 cubed plus 2 fourths and so on. So you want to divide by 2 again, and you get 10, and then 10 divided by 2, you get 5, and then 5 divided by 2 is 2.5. You just use the 2. You don't use the 0.5. And because that's not a whole 2, it's only 2 2's. And then you divide that 2 by 2, and you have 1. Well, if you add up 40 and 20, 40, 60, 70, 75, 77, 78. So you have a total of 78 2's. That if you prime factor this all out, you'd have 78 2's. All right, so that's good. Now you have to match that up with some 5's. So if you did the 5's and divided them out, you'd have 80 divided by 5, and then whatever that was divided by 5, you'll find out that there's 19 of them. Now, you have to match each 5 with 3 of the 2's. So what I did here is I said, okay, well, if there's 19 5's, and you have to match it with 3 2's, well, 19 times 3 is 57. So the maximum number of 2's you can use is 57 out of that total of 78. You have way more 2's than what you'll need, which is usually what happens. And so basically, that means that you can fit all those, you can fit 3 2's with each 5. That was just a double check to make sure you had enough 2's. And so we do. So the maximum value would be 40 to the exponent 19. And because it asks the exponent to the greatest power, this is the greatest power, so the exponent would be 19, okay, which is D. And that's the answer to that one. Okay, now let's look at question number 3. Question number 3 states 17 lines drawn in a plane and with no 3 concurrent and no 2 parallel, divide the plane into closed regions, bounded on all sides, and open regions. The number of closed regions is. Now, one of the things before I go on to this is the maximum number of closed regions. It's not any number, because you could go on forever, and, well, not forever, but for a long time, and maybe not create any closed regions. So in order to be able to create a question like this, you have to say the maximum number, okay? So this is a maximum number of closed regions. So a chart was made when you had no lines, you have 0 closed regions. When you have 1 line, like in this case, you still don't have any closed regions. When you have 2 lines, you still don't have any closed regions made by the lines themselves. It's not the edge of the plane, it's actually the lines themselves. So you still have 0, but when you get to 3, you can actually, let's just do one with 3. You can make 1 closed region. And so there's the maximum, 1 closed region. So if you notice at 3, we add 1 to that, okay? So we've got 0, to 1. So we've got that. Now, when you do 4, and I've actually drawn one with 4 here, notice the maximum number of closed regions, 1, 2, 3 closed regions. So I've written 3 here. And then you can see this add 1, add 2. Oh, if it probably is going to be add 3, add 4, and it is. Okay, so as you add these in. So you've got all those number of closed regions. But the key is, if you had 6, what did you add? You added up to 4. So it was the sum of a series up to 4. If you had 5, it was the sum of a series up to 3. So if you went up to 7 lines, the sum of the series would be up to 5. If you went up to 10, it would be up to, well, 2 less, which is 8. And in this case, at 17 lines, we have added 15 regions, so 2 less. Okay, just like here at 6, we added 1 plus 2 plus 3 plus 4, so there's 4. Okay, like 4 regions, so 17 lines, 15 regions. So you go up to this, 1 plus 2 plus 3 plus 4, all the way up to plus 15. That's the sum of a series, 15 numbers times the average was 15 plus 1 is 16 divided by 2. So you've got 2 divided by 2. 15 times 16 divided by 2 is 120, and that's how you get the answer. All right, so this is the sum of a series. If you don't know how to do that, you may want to double check. In fact, here, I'll tell you right now, because this is key to a couple other questions that we're going to do. Sum of a series, you always take the number of numbers, so you want to know how many numbers there are, and then you multiply that by the average. Now, the number of numbers very clearly here is 15 numbers. All right, if you've got each consecutively going up by 1, there's 15 numbers. So that's where this 15 came from. The average isn't so clear to everyone. The average, basically, if you took this 15 plus 1 and you wanted to distribute, that gives you 16 points altogether, and you want to distribute them equally, you divide by 2. And when you divide 16, so this gives you 16, and divide that by 2, you get an 8 and an 8. And that is the average of these two numbers. Now, if you want to take the average of the next two numbers, 2 plus 14, well, 2 plus 14 is 16, and the average of 16 is 8. And then you'll find that's all along. So all you need to do, though, is just take the first and the last, and that will give you the average for the whole thing. Because every time you go down 1, you're going up another 1. So the average of those two numbers is always going to be the same. So the average is 8. Okay, so you always take the first and the last and divide it by 8. All right, that's if it's going up by 1s. Okay, so, and divide by 2, I mean, not divide by 8. And the answer is 8. Divide by 2. So you always take the first, last, divide by 2, and that's this part here. That's the average, and the number of numbers is here. So that's how you get that. And this is critical for some other questions in this whole assignment. Okay, so here's another question. Question number 5. Find the sum of all possible 4-digit numbers that can be used forming the digits 2, 4, 5, 6, 7, and 8 with no repeated digits. So in this case, I want to know how many, like you could list them all, but that'd be crazy because there are a lot of numbers. So the first thing is you find the number of numbers to add. So you know that there are 4 digits, 1, 2, 3, 4, and there are 6, or 4 digits for that number, and there are 6 digits to choose from. And the 6 digits are 2, 4, 5, 6, 7, 8. So for the very first one, you have 6 that you can choose from. Then you have 5, then you have 4, and 3, and that gives you 360. If you want more detail with that, please go to the other video where I give some more on the hints. Okay, so you've got 360 numbers that you can make. Now, since you have 360 numbers, you need to, and order doesn't matter, you need to find the sum of each column because you've got all these columns of numbers. You've got one number after another, and you've got all the columns that will be created with all the digits. So if you knew the sum of each column, then you could, and the sum of each column will be the same because it's using all the same digits over and over again, then you can find out the sum of all these 360 numbers. So because each number each column has an equal number of each digit, you know there are 360 numbers. Divide it by 6, because there's 6 digits, equals 60 of each digit. Okay? So you have 62, 64, 65, 66s, 67s, and 68s in each column. So if this was column of numbers, you would have each column, you'd have 62, 64s, and so on to make 360. So now you multiply that by 60, because we know there's 60 of each, and that gives you a total of 1,920. So if you added up this column, you'd have 1,920. Okay? If you add up this column, you have 1,920. And if you add up this column, 1,920, this column, 1,920. That's 4 columns. The key, though, is that you need to figure out what happens when you carry. So in this very first column, you have 1,920 as a total. You put the 0 down, and you carry the 192. Now you take that 192 and you add it to all these. Well, you know that the total to this is 1,920 plus 192 that you carried. So now you have 2,012. So you write down the 2 and you carry the 211. Okay, so you carry that 211. Now you take that 211, you add it to all these numbers. You know the sum is 1920, so 211 plus 1920 will give you 2,131. So you put the 1 down, you carry the 213 up here, okay? So now you have that 213 plus 1,920. You add that all up, and you get 2,133, okay? And you write that down, and here is the sum, because you've just added it all up, and that's your answer right there. Okay, now let's go over and look at the other questions. All right, so for question number 2, it states the numbers 1, 6, 11, 16 are written in order in a book, 50 to a page, beginning on page 1. The number 12,346 will be written on page, and you have to figure it out. Now, the numbers 1, 6, 11, and 16. So you've got 1, 6, 11, 16, and so on, are written 50 to a page. So basically you keep writing all these numbers, and there's 50 of those numbers on each page, and you get to the next 50 numbers and so on. So how do you find out where the number, it says 12,346. 12,346. What page is that number? That's basically what it's asking. So and sort of a neat way, and this is a neat trick, and always to think about this in math when you get to these types of questions, is this is kind of awkward working with 1, 6, 11, 16. But if I worked with something else that was a little easier, like 5, 10, 15, 20, then I could figure out how many numbers of 50 would be and so on. So that's basically what this solution states. It says if 4 is added to each number, then the sequence becomes 5, 10, 15, 20. It just makes it easier. That's basically all that's happening here. So you can see the answer much easier. And the number 12,346 will be represented by the number 12,350 because you add another 4. Now you know, like it's easily divisible and you can see it, okay? So you can't just change this without changing that, basically. So we've changed this to this now, and that's what's happened here, because it will be the same idea, the same number of numbers. So in the new sequence, if 50 numbers are written on each page, the new sequence 250 will be the last number on the first page, okay? So basically, 5 times 50 is 250, okay, because we're doing it by 5s. So that will give you the 250 will be the last number on the first page. 500 would be the last number on the second page. So you've got 500, second page, and so on. So you can keep going. So 750 on the third page, and 1,000 on the fourth, and so on, okay? So what you want to do then is divide this number, 12,350 by 250, because that will tell you the number of pages. So that gives you 49.4. And the number 12,346, therefore, will be found on the page after 49, because this is 49.4. So it's the same idea. It's going to be on the next page, and that would be page 50, and that's your answer. Okay? So we basically, in this question, what we've done is you've changed the sequence so that it looks a little so it is easier to calculate. You can see it divisible, but it's by 5s. So then you can figure out how many numbers would be on each page, and then you figure out how many pages there are, and from there you can calculate. Okay, so that's question number 2. Question number 4 is a little bit more complicated because you've got a couple of things to do here. And basically question number 4 says the multiples of 3 and 7 are removed from the series 1 plus 2 plus 3 plus all the way up to plus 150. The resulting sum is, okay, so basically it says from the sum of the original series, we subtract the multiples of 3 and the multiples of 7, and then add back in the multiples of 21, because those were subtracted twice. It was subtracted, it's a multiple of 3, so it was subtracted in the first when you subtract the multiple of 3, and then it was also subtracted when you multiplied 7, or when you took out the multiples of 7. So you need to put it back in, one of them back in, and so that's why you add in the multiples of 21. All right, so how do you do that? Well, first of all, you want to find the sum of the original series. And the sum of the series is the number of numbers in that series times the average. And the average is the first number plus the last number, and divide that by 2. And that's what I explained in question number 3 back before when I was explaining how to do this. So you take the first plus the last, and you divide by 2. That gives you the average. The number of numbers is the last term minus the term before the first term. So in this case, the term before 1 would be 0. So there are 150 minus 1, which is 150 numbers. Now, if it was every third one, you'd have to divide by 3. Every 7th one, you divide by 7. So in this case, there's 150 numbers. The average is 151 divided by 2. So that is the sum of the series. Now you have to take out all the multiples of 3. So 3, 6, 9, 12, all the way up to 150. So you basically have 150 numbers, and you divide that by 3 to give you the number of numbers. Okay, so 150 divide by 3, because you only want every third one. And so if you notice, it's 6 underneath here, and that's because you have the average is 153, 150 plus 3 divided by 2. So this is basically 3 times 2 down here. Okay, so you've got the number of numbers times the average. And then you want to do the same with the 7. Now, the interesting thing about 7 is that 7 will not divide into 150. The next smallest number that 7 is divisible into is 147, and that's 21 times. So you go up to 147. So the 147 numbers divided by 7 will give you, or 107, you go up to 147, divide by that by 7, and that gives you the number of numbers. So that's in this 14, because this is 2 times 14. Now, 154 is 147 plus 7. Okay, that gives you, because the last number is 147, the first number would have been 7 plus 14 plus 21 and so on. Okay, so 147 plus 7 is 154 divided by 2, gives you the average. And then you have 147 divided by 7 also here, and that's included. Okay, and for the last one, I'm going to do the same thing, except in this one you want to is 21. So in this case, you went up to 147 because 21 will not go in divided to 150 since 7 won't. So 147 divided by 21 gives you the number of numbers. And then you have the average is 147 plus 21, which is 168, and divide that by 2. And that's why you have 42, because it's 21 times 2 in the denominator. And so you just calculate that all, and you get this as your final answer. Okay, one more to go. Question number 8. Question number 8 says the sum of the first n series of 5n squared minus 2n. The rth term is, term is. Now, basically, all this is saying is if you substituted in the r, like what would that be? Because you don't know what term it is. So the answer says the rth term can be found by taking the first r terms and subtracting the first r minus 1 terms. And what you're left with is that rth term. Now, let's look at this. So the question itself, for question number 8, gave you 5n squared minus 2n. Now, when you've got that, you first of all take the, and subtracting the first r minus 1. So you take the first r, so you take this and you substitute r into here. So you have 5r squared minus 2r. Now you want to subtract the r minus 1 term. So it would be minus 5 times that r minus 1 plus, because you're subtracting. So you need to change that sign. And when you change the sign, you have that. And now when you solve for all of this, you get this as your answer. Okay? So you can do that algebra yourself. See that. That's it for contortions number 2.